going to be streamed. Let me see if I can launch the. No, it shouldn't be Edson key in the TT. I changed that. It should be. Oh, there we go. There it's coming. It's coming. It's coming. Okay. Now I think the streamer from before unchecked some stuff. I can see here excellent connection coming back. Let me wait a bit. Let me be sure I see the feedback on the YouTube side, because it's receiving some stream. Okay, and if someone can check on YouTube on their side, because I don't see anything in the replay. Come on, I see that there's an excellent connection. Connect to streaming software. Okay. Oh yeah. Oh, I see myself in the chat. Awesome. I'm there. I don't know the delay we have. Things get reconciled. I'm so happy about it. Okay. Anyway, Edson is on PTO, so I'm replacing him today, and I'm really, really happy to about our guest. Yesterday he ran a fantastic event, DevNation Day India, and today he's back for a tech talk. And let me bring him on stage. Hi, Karan. How are you?
Hey, Sebi, I'm doing good. How are you?
Yeah, a bit stressed because had some issues with streaming, but you know how this thing goes. But looks like
Fun part, Sebi. That's the fun part.
That's the fun part. Yeah, and probably the people on YouTube have some delay and they see me struggling, but that's not a problem. We don't have a lot of time, but I love the abstract. What if I could just do git commit, git push, and there it goes, my stuff.
Are done. Yes, two things for you. Correct.
Okay. Hey, the stage is yours. Share your screen as soon as your
okay. Thanks, Sebi. Let me share my screen. You guys can verify if you can see and hear me clearly. Audio is good, and the screen. How about screen share?
Yeah, screen share is on stage. Okay, the stage is yours.
Okay, fantastic. Hello. Good morning, good afternoon, good evening from wherever you are watching this live stream. I'm Karan, working with Sebi and Anna and Edson and all of the Red Hat developer team here at Red Hat. I am a senior principal architect and developer evangelist, and today I'm going to show you GitHub Actions and OpenShift and how you can supercharge your software development loops. So let's go into the weeds of automation. Okay, I'm not going to go over this, but yes, you can follow me on LinkedIn or Twitter if you want to. I'll share some good content for you. Okay, so the ride for today gonna be very bumpy. So get your seatbelts on because we're gonna switch gears very often. So we're gonna talk about GitHub, OpenShift, Kubernetes, Agile DevOps, and CI/CD pipelines, and showing you a view from the outer space how Agile DevOps, CI/CD, GitOps look like, and then walking you through in the weeds of GitHub Actions, event types, and core concept of GitHub Actions, and then doing some surgery on GitHub Actions workflow file that you will gonna learn a lot from this, and then going through not one but two live demos in front of you, and we're gonna do some gaming as well. Okay, so let's go, people. So in 10 seconds, this is Git and this is GitHub. You guys know this already. I know this. However, for the people who would be watching this maybe 2 years from now, so Git was first developed in 2005 by the one and only Linus Torvalds. While he was building the Linux kernel, he thought like, there has to be a better way to manage software. There has to be a better version control. So what he did is he just invented one. He invented Git. And then from rest of the things are history. And then so if you see on the timeline side, okay, Linux 1991, and then Red Hat came in 1993, started to do enterprise Linux distributions, and then Git came up along in 2005. GitHub picked up Git and make it wonderful with the GitHub SaaS offering. Then OpenShift came along in 2011. When there was no containers, I guess, at least no Docker, or maybe, it was in its diaper time. But Kubernetes was not there, and Kubernetes came in 2014, and then GitLab picked up and became another hosting provider for Git. So this is a brief timeline of Git versus GitHub. Okay, changing gears again. All right, containers. We talk about containers, we talk about microservices. So, what does go inside these things? So, containers contain source code. We know this. It also comes with dependencies and binaries and libraries. So, all of this forms together a container which solves the portability problem of the code base, right? So, it does not work on my machine, is now a history. It will definitely work on your machine using the power of containers. Okay, and a lot of containers combined makes microservices or multiple microservices. So, and then when we have multiple microservices, it forms the microservice Death Star. So I haven't coined this term. Some great smart people coined this term. And the Death Star looks like the black one and the blue one. So one is from Amazon, Amazon's public public talk, and then the other one is from Netflix. So, however, this is how a microservices Death Star look like, in which you have tens and hundreds and even thousands of microservices running in tandem, giving you the actual software experience for the 21st century. Now, the magic is how we going to manage all these microservices and hundreds and thousands of containers. So there has to be a better way to do it. Containers and Kubernetes. So Kubernetes is now the de facto container orchestration open source solution, which people love. And let's talk about what is Kubernetes. And Wikipedia, thank you. So Kubernetes is an open source orchestration software for deploying and managing and scaling containers. Fantastic, we know this. But what is OpenShift? Well, in one line or in three words, OpenShift is Kubernetes. It's an enterprise-ready Kubernetes container platform which provides you a consistent application platform across hybrid cloud, across on-prem, all other public cloud providers, even at the edge. So think about this. The exact mechanism or exact process through which you can deploy an app on the edge, as well as you follow the same procedures and same principles to deploy it on premise, and carry forward the same procedures and principles to deploy on any of the public clouds. So this is fantastic. This is the power of OpenShift, which allows you to give you a consistent application across on-prem and multi-cloud environments. All right. Okay, again, changing gears. So what is agile and DevOps, and how can we build maintainable and sustainable softwares? So here we're coming to talk about agile and DevOps and CI/CD. So how does it look like if one has to visualize all the three keywords? How would it look like? So it will look like like an egg in an egg in an egg. Okay, so sorry, bad joke. So agile is a large framework, and it's a principle, it's a philosophy of software development. And agile is not new. Agile is there since last 2-3 decades out here. So it provides you a framework so that you can build great softwares for your businesses. DevOps, on the other hand, is practice and a mindset which uses principles of agile to help you build maintainable softwares. And CI/CD is basically a DevOps tactics, so that you can follow continuous integration, continuous deployment, and continued feedback loop while you continuously produce new softwares. So this is how agile, DevOps, and CI/CD look like in a single pane of glass. I hope this clarifies the situation here. And moving on to CI/CD pipeline, can we realize CI/CD pipelines? So sure. So a great developer will basically write some code, push this into version control, which is Git, for the sake. And once it is into Git, at that point the continuous integration journey begins. And then the software, the code that the dev has written, it will be built, it will be unit tested. So this is part of continuous integration. And then from there, once the code is in a good shape, or whatever you're building is in good shape, you will deploy it somewhere on a server, on a serverless environment, or maybe on a cloud, or your favorite compute instance, or whatever you want to deploy to. So you'll deploy it, you will auto test it, you will write some automation test to auto test that, you'll deploy it to production, and then you will measure and validate, right? And During the process, you will have a continuous production feedback loop coming back to the developers so that they can iterate on the new versions. So holistically, this is how CI and CD looks like in a full software development pipeline. And we are going to go over this practically in a few slides. Okay, changing gears again. So let's go and bust our egg analogy, and let's talk about how would this look like from outer space. Agile, DevOps, CI/CD, GitOps. There are lots many tools up coming up. There are lot many keywords are coming. GitOps. So what the heck is that, right? So we have talked about Agile. So Agile is a framework, and DevOps is an Agile culture, and CI/CD basically DevOps is a tactics, right? Which uses CI and CD. So we have done this part, but now all of a sudden there is a new keyword which is coming up: GitOps. What is GitOps? So GitOps, if you see, GitOps uses CI part from DevOps. So GitOps. It uses CI part from the DevOps part, and for deployment it uses Kubernetes. So continuous deployment, it's something that GitOps manages by its own. And then there is one more item to it called as continuous operations. So all the state is being stored in Git, being deployed on Kubernetes, and as soon as there is a change in your Git repository, automatically Argo CD tools like Argo CD or Flux or others which are coming up, which are implementing GitOps, can do continuous operation for you. So this is how the new world with GitOps look like. Okay, changing gears again and coming back to the topic of the day, which is GitHub Actions. So where does GitHub Action is placed in all this outer space universe view? So this is how it looks like. So GitHub Actions basically works with GitHub. It does not work with any other provider of Git, because it's a GitHub technology or GitHub feature. However, it is derived from Git. So Git, if you will store your code on a Git repository, and then you will implement some checks, which we're going to talk about in a few slides. So GitHub Action is a CI/CD platform. It's not a GitOps platform, right? So GitHub Actions is a CI/CD platform. However, Argo CD is a GitOps tool. So this is how one can differentiate between these tools. So as soon as there's an event in your GitHub repository, you could control the way automation works. And like, for example, okay, as soon as I push something, there has to be a new build, and then the container should get pushed to the repository container registry, and then my container should be deployed on my X, Y, and Z Kubernetes cluster. So that's how you can do this on GitHub Actions. Yeah, I covered that. You will have apps. Apps will get stored in Git repositories. GitHub Action Git will get triggered and then eventually deployed on Kubernetes. So here's a developer. So developer will basically write some code, and once the code is in good shape, or maybe Git push is a good practice. So if you do a Git push or a Git PR, create PR, merge PR, create a tag, create a release, these kinds of events in your software development pipeline, it will trigger. And this is not the exhaustive list. We're going to talk about that in the next slide. But a developer will do these things in his standard software development, and which will trigger a GitHub action that we have to code. We have to write those GitHub action workflow flies. But yeah, as soon as there's an action, we will have a reaction to it, which means one can ask GitHub to deploy it to development environment, staging environment, or production environment, or onto Kubernetes, onto OpenShift, onto any other Kubernetes distribution, or even you could deploy it to non-Kubernetes based compute platforms as well. So GitHub Action does not stop there. But yeah, for sake of our talk today, we're gonna stick to Kubernetes and OpenShift. And here are the action GitHub Actions event types, like, okay, page build, project created, and you can also use this with your Scrum methodology of Kanban boards. If there is a new card created, please do an action, if there is a new fork, if there is a new issue. So GitHub gives you a lot of flexibility to enable all types of automation for developer. So you can use these all action types to trigger your CI/CD pipeline. Okay, so what are GitHub Actions and what are the core concepts? So at the core, we have the actual task or actual action that needs to be performed, which belongs to a step, and one step can have multiple actions, and a job can have multiple steps, and a workflow can have multiple jobs, and then workflows are being deployed on runners. So runners could be a shared runner from GitHub, or else you can also deploy your own private runners on your compute environment. So yeah, it gives you a lot of flexibility on that side. So this is basically the core concept. All the workload files would be designed on this core concept. And GitHub Action is if this then that kind of automation, workflow, and triggers for GitHub repository. So you can literally tame it the way you like to see your software CI/CD pipeline to look like. And here is a sample workflow file that will look like. So I'll begin from the start. So you'll basically define a trigger point, like, okay, in here from line number 3 to 6, what I'm telling GitHub is, hey, as soon as I do a pull request on branch main, you need to trigger this action. So it's literally this simple. And then you will define some environment variables as secrets, which you will define in your Git repository, which you would later on use in your workflow files. So people who are familiar with YAML, they know this. It's pretty simple to do. You will define it and then later use down in your program. You can also use regular environment variables like environment is equals to dev or prod, or Kubernetes cluster, North America cluster, Asia Pacific, whatever you like to do. And then we will define some jobs. Under jobs, we will define steps. And we will say, okay, GitHub, please go and do checkout to my branch, to my main branch, and here we are basically using these called as actions. Okay, wait a minute. Okay, we are using action this slash checkout. So it is basically a reusable component of GitHub Action that we can call out in our program. We don't need to basically literally go and write these things. And then as we move on, we can write some shell commands like, hey, run docker build, docker login, docker push, sed or cut, grep, pipe, whatever. And then we can also use GitHub Actions written by other providers. For example, here Red Hat has published a GitHub action called as OC login. So this is a GitHub action that we are simply using, calling out, and providing our own variables like, hey GitHub, hey Red Hat OC login action, please use this URL, please use this token, and this is my namespace to login. So it will help you. It will log in with your credentials that you will provide to it, and then we're telling the deployer like, hey, OC apply -f bam 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 YAML file. So it will simply go and just run that YAML file for you. So this is how a workflow look like on GitHub Action. Moving on to next, talking about GitHub Actions from providers. Here is the list of GitHub Actions provided by Red Hat. So you can literally go and pick up these actions and deploy it and use it in your own workflow files. You can follow these links. My colleagues Anna and Sebi can give you the link, or maybe I can just copy and paste later on to this. So yeah, for example, Knative Service Manager, it helps you to deploy Knative services and OpenShift login, right? And then Builder and push to registry, Podman login. So these are reusable GitHub actions that anyone can use to interact with their respective clusters, OpenShift clusters. Okay, so in today's live demo, we're gonna use multiple of these extensions, or not extensions, but multiple of these GitHub actions right from the marketplace. Okay, let's go to the demo part, the most complex stuff. So I'm gonna show you two demos, part 1 and part 2. In part 1, standard software development practice, there is a developer who is writing code on local, and then he will do, hey, git push origin dev, like we all do this. As soon as you will do that, the code will get pushed to GitHub, and then it will trigger some actions. then the developer will create a pull request from his dev branch or from his feature branch to main branch, which will again trigger a GitHub action. And then a senior developer or his colleague who would be monitoring or kind of doing the quality checks on the code, once he is satisfied with the work, he will simply go and merge the pull request, and this will again trigger up an event. And then finally, once the team is ready to release the software that they were building on, they will create a tag, they can release the software. And then all of these events happening from the developers end will result in our GitHub actions. And then we're gonna code our business logic on to deploy this onto OpenShift environment. So that's we gonna do right now. And then the part two of the demo is, you know it will not look cool if it does not involve serverless. So that's why I've used serverless, just to make this exciting. The part of the demo is, okay, great, we can deploy it on a pod, but can we do serverless also? So the answer is is a big yes, we can do it, and we're gonna see how does it look like to do it. I mean, the reason I intentionally added this thing is to show you, how simple it is to reuse the existing GitHub actions which are already there, so you don't need to write some code. So in this demo number 2, we're gonna use some more actions. Okay, demo. Let's go. So what I'm gonna do next is I'm gonna go to my OpenShift cluster. So this is my OpenShift cluster. So there is no cheating at the moment. You can see all. So these are my old services running, and there are no pods on this. And this is deployment. Nothing is here. We also have serverless, and I don't have anything defined on my serverless environment. So let's go to demo number 1, part 1, and we are going to do a racing game app. And I encourage you guys to play once it is deployed, and let's see if this gets deployed or not. Okay, so let's go to our git repository. All right, so here's my Git repository. I'm having all my code in here, and I'm a developer, and I've done I've done the actual changes. And I'm gonna go and talk about this file later on in a moment, but let's see how this look like. So okay, all good. I'm in my dev branch. I want to do a commit. Okay, so I'll do an ugly commit here. Echo. Okay, cho. Okay, adding a dummy line in my README file, because that's the simplest change I can do right now. Okay, git status atus. Okay, good. I have one file in here which needs to be fixed. Okay, commit. Okay, git add dot git commit my same changes. And again, this is the important point, right? Git push origin dev. So I'm basically pushing my change from my local onto Git repository. So nothing serious here. Okay, changes are being pushed. Okay, cool. No magic until now. Okay, wait for the magic. Okay, so I'll go to my main branch. I'm a developer, and I will say, okay, Sebi, I'm doing a pull request on this project for you to review. And hey, Sebi, can you review, please? Okay, I'll do a push, and you can see there is just one dummy line in my README file. I will create a pull request, and this is where magic begins. I have defined a GitHub action. I'm going to show you this, and GitHub action will detect this change, and suddenly it will show you this, like, okay, something is happening, something is cooking up. I'll go and check the details. How does it look like? Okay, this is an action, a full-blown CI/CD pipeline being right now triggered up. It is building my container image, and then it will log into Docker. I mean, these are the things that you will do manually use on the CLI, right? So people who know this stuff, they can relate to this. You will do all of these things manually: Docker login, Docker push, and then once it is pushed to Docker image, we would be basically renaming changing the line in your YAML file, authenticating against an OpenShift cluster or Kubernetes cluster, and then deploying it onto the cluster. But yeah, this automation pipeline is doing everything for me. And you can see, okay, so it has deployed. And one more additional thingy that which I have added in here is Okay, as soon as it is done, I will make Sebi's life happy by adding a automated comment. So Sebi will go this. Okay, what current has done? Let me see. Okay, and I've invoked a GitHub bot to basically add a new comment, which includes my deployment URL, which means Sebi does not need to do anything, by the way. Sebi, so if you're listening, you know what? I'm making life easy. Okay, so let's see if this app is up and running. Oh, boom, this app is up and running. We have just deployed an app, and again, no cheating here. Let's go and see. Okay, there's a new deployment came up here, and there is a new pod which is up just now. So again, no cheating, and demo guards are with me. I'll start this, and tan tan. Okay, slightly slower. I don't like latency in games. Okay, boom. We have a new game deployed, and this is uh, a new game which you guys can play even after this call of this live stream. But yes, you've seen this. Like I just deployed a software from scratch using just GitHub, Git commit and Git push, and just doing the standard operations. Right? Okay, I'll play this later on, and I will close this, and I will also uh, give this to my friends. Maybe I'm giving you on chat. You can later post on the right streaming handles. Okay, coming back to our topic of the day. All right, so we have done one part, which is so Sebi has basically Sebi has just checked my code. He has not merged it. So okay, let's do some merging. So Sebi will go, okay, Karan, your code looks good. Let me merge. He will do a merge, and internally merge will again kick off one more event, which I can go and check out in actions. Okay, let's go to actions, and boom, there is another build of my app is happening in this, and basically the same, nothing serious in here. So let it run. Let me go and walk you through my actual GitHub YAML file. So let's go to this one. As I told you before, it is doing it is detecting the pull request on the main branch, and then it is setting some environment variables, quay, username, password, pull secrets, and OpenShift URL and token. So this is all stored in my OpenShift, in my Git repository. So let me go and share you with that as well. That's an interesting part you guys should know. So if you go to settings, if you go to secrets, you will define those environment variables or the secrets in here, and these are pro tip. It's just one time. You can't view this. You can just update it and delete it. So it's a good thing. Yes, so you will define it here, and you can access it like this: secrets dot da da da, right? And I'm storing this into an environment variable. Then moving on to this, I'm doing a checkout using an action. I'm getting the SHA of my commit. I'm just using some, I don't want Docker build to just take a lot of time. I'm using some layer caching enabled. Again, these are actions built by someone else, some nice human being. I'm just using the code. And then we are running some commands: docker build, docker run, docker login, docker push, and tag and sed, right? And then we will use a Red Hat action for OC login, and then deploying the YAML file, and then getting out the actual route, and using another action to create a new comment in using the bot, right? So full automation, as well as some reactions to it, like rocket or your favorite smiley. For fans of OpenShift, here's the YAML file. Nothing serious again. It's a secret, it's a service, it's a deployment, it's a route. So it's a standard OpenShift YAML file. So this is how it looks like. So let's see, where is our action which okay, so the merge request is done and my action is completed. Fantastic. So we are done. If I go to this, we are done with step number 2. Step number 3, oh, actually, we have done step number 3 as well. Like merge request has been done, a new build has been created. Let's go and see what happens when you do a tag and release. So okay, so I'll go and here, and I'll do okay, git tag, yeah, version, let's say version number 2.0, and I'm doing a 2.0 tag. So I'm tagging my repository, and then git push origin. Okay, what happened to my keyboard? Come on, keyboard. Right. Control C. ZSH is not supporting me today, or maybe I have installed so many plugins. Come on, ZSH. Okay. Come on. Push origin v 2.0. Okay, sorry about that. So I'm just using CLI to tag it and then pushing my new tag onto GitHub. So this will do a new push, and as I told you before, it will go ahead and trigger one more action for me. Okay, yes, it is being running. So meanwhile this is running. So again, nothing fancy in here. It's the same thing, but just to give you guys a full blown overview. Let us see how the repo looks like, right? So to make this magic happen, you need to create a directory called as .github/.workflows. Under this repository, you will define all your GitHub Action workflow files. So for example, this is my workflow file number 1, which will do on pull request to main. This is file number 2, which will do push to main, which will get triggered on push to main. This is number 3, which will get triggered on push with tags if I'm doing a tag push to my repository. This is number 4, which I'm using if there is a new release, so an event will occur. So this is how I am defining and telling GitHub to which CI/CD pipeline to trigger on what event. So this is where the magic looks like. Okay, so if you can see this, my application has been redeployed for the third time when I created a new tag. Let us go and see the last part, which is creating a release. Okay, tag version 2.0, create a new release. Okay. Okay, so congrats. V 2.0, okay, 2.0 is out. Excited, I'm having it. Okay. CONGRATS, congrats. Okay. Okay, this is my new release. I'm doing a publish release, and look, if you look at this file, as soon as I do this, it will detect a change, like there is a new release event occurred, and it will simply go and trigger one more pipeline for me. So if you can see this, the simplicity, we are adopting GitHub and using the same principles that we used to do since last 2008, since GitHub came up. We are using the same principles and the same procedures. However, plugging this time with OpenShift and Kubernetes to deploy your softwares on the fly without much of hassle. Okay, so let this run. And now we're gonna go and talk about our next demo, which is serverless. I think I still have some time left. And serverless, we're gonna use some more GitHub actions to show you guys, what is the, I can show you what is the limit, but to show you guys around, how does it look like with other actions. So let us go and first of all, read out the YAML file. Okay, so I'm gonna do this on dev branch. And then again, same environment variables, nothing fancy here, but here I'm using, instead of last time, so if I go again back to this file, last time I was using docker build, docker login, docker push, docker push, right? This time I'm just using build, which is a Red Hat action to automate that part. So building the container image using build, and then using push to registry, another Red Hat action to help you push the containers to your preferred registry. In this case, I'm using Quay, providing the username and the passwords, which are coming from the secrets. And then, these two plugins. So I'm actually not writing any code. I'm just, using the plugin, build, and then and you push to registry, and then log into OpenShift. And then, here is then one more plugin. So I'm continuously using plugins. If you see this right from here, so this is plugin 1. This is, I shouldn't call it plugin. This is action 1. action 2, action 3, action 4. So basically, all the uses in action 5 and 6, right? And then I'm using another action called as knative kn server service manager, which will deploy my knative service using the container image. And since my registry image is private, I need to provide credentials. So as soon as I do it, it will launch a new knative serving for my serverless function. And then I'm just fetching out the route name, and then as last time, we are putting out or outputting the route onto a GitHub comment. Okay, so let's do this. It's pretty standard now. You guys are already up to speed. Okay, so let's go to check out a native dev. This is my branch. I'm gonna do the change. Okay, I'll again do one serious change here. Echo, adding a dummy line again. Okay, and then push git commit changes in let's say knative knative branch, and git push origin knative dev. Before I do it, let me go and show you that there's no cheating going on. Okay, so I just have one container because my last deployment has gave me one container, three deployments, but one of them are in use. Nothing inside servings. There is no serving available at the moment because I have not deployed any. Okay. Next, I will go and do a push. Pushed to GitHub. Let's go back to GitHub and GitHub, and okay, it is telling me already that okay, knative dev has a new change a minute ago. What do you want to do? I want to compare and pull. So as soon as I do a pull request to my dev branch, I want to do in dev, right? I mean, I have coded to do trigger this into dev. I think I should show you. Yeah, dev. So this will get triggered if I do this PR on dev branch. I can change it to main, but you got an idea. So that's the reason I will do it to dev. Okay. Okay. So again, just one line changed, and I'll do a PR. Conflicts must be resolved. Readme.md. Resolve conflicts. Let us see. Okay, there are some conflicts in here. Should we? Yep. Should solve it, hopefully. Markers resolve, commit and merge. Let's see. Come on. Oh, yes. So now it has triggered my action. So as you can see, the name is a name which is displayed before PR merge as key native serving. So just to verify, it's the same name of GitHub workflow which is being triggered at the moment. And if you see, it is basically building up all the knative service manager. It will do a checkout. It will use Docker caching to make it slightly faster. And then it will build my container using the build GitHub action. It's doing that at the moment. And then it will simply push it to the registry using another GitHub action, which is called push to registry. And pushing is completed. Looks like it's still running. Okay, push is done, successfully pushed, and then it is logging into OpenShift environment and setting the context. It is done, and then it is creating a knative serving, which is basically running this command under the hoods. Let's see if this is successful or not. Waiting for the revision. Meanwhile, let's go and head out to here. Okay, yes, something is happening up. Look at this one, serving. I've got a new knative serving object here. And if you see, the changes has been completed. Let us go to OpenShift and verify, yes, conditions are okay. And I want to check the pods. Are there any pods at the moment? Yes, there is one pod, which is came up because we have just deployed it. If we don't use it, it will go away, right? And just to verify, coming back again to my pull request and click on this again, and yes. So 32 seconds back, GitHub bot have told me that I have now a new URL. Now I have the same app deployed in two different ways. One is standard pod, which will Kubernetes deployment type. This one is a serverless pod. So if I open this up again, it will simply open up the same game, right? Nothing fancy about it. Um, and if I go to, I think, you know what, we need to wait a few. I think it's 5 minutes, if I'm not wrong, to kind of destroy this pod. But anyways, we can see. So the pod is running. We'll stop it out. We'll not do any hits. Let's head out to the developers view and see how does it look like.
Hey, Karen,
Oh,
I'm joining.
hey, Sabi.
Hey, it's awesome stuff. We are a bit over time, but
Okay. Yeah, I mean, we
we
are
can wait
almost.
for the pot to scale down to zero. If you have using the
Yeah,
default,
sure,
it
sure,
should, it
sure.
should be 1 minute. Should be in 1 minute. The pot should scale back to zero if you use the defaults, I think. But
Oh, yeah, yeah.
yeah, yeah,
Anyways, Sabi, my demo's done, so everything worked fine.
yeah, yeah. It
And
was awesome stuff.
so yes.
I was
So I'm
really
open for
impressed.
any questions if you guys have here. Sabi, if you can help
Yeah.
me with some
Well,
questions.
I'm checking the chat. There are no questions. I think people
Mhm.
were really focused, and it was really clear because GitHub Action you push. I shared the link of the game, so maybe people are playing. You know what? Maybe people are playing. They were listening to you while playing the game. That could be also the case. I click on the link and I say, no, I will wait. I will play a bit the game after that. But I see no questions so far. People, you have 1 minute. If you have a question, it's right now. I don't know if we have someone. Well, we have Anna in the background. If maybe she has a question, I don't know. You can give me a sign if you have a question or not. No, no. But anyway, the link to the slides and maybe the link to the repo is that. Oh, there's a question arriving from Abe. I have a question. Okay, shoot then.
You should, yes.
So let's see the question. And yeah, everyone will receive an email, I think, with the link to the slides, the recording of this.
Yeah.
Of course, there's a replay available. It's already available. The URL that you are watching right now on YouTube is the replay, and there we have the question. So what is the pros and the cons with this compared to pipelines Tecton? Oh yeah, I could have asked this question. So how does it compare with Tecton?
Yeah. So, in my opinion, Tecton pipelines provides you even higher or even better way to visualize or kind of deploy your systems as you like it. What else? Pros and cons with that's a good question. I should have thought about that.
Mhm.
Mm,
Yeah. I,
I
I
mean,
would I would love that GitHub Actions
one
were based on Tecton. Imagine if that was the case. Then we should have pipelines that you can deploy on GitHub using GitHub, but maybe on premise. If GitLab runners were using the same, also based on Tecton, we should
yeah.
not. We
And I
wouldn't
mean,
have
one con is that GitHub Actions is specific to GitHub, right? You can't run it anywhere else. So, but pipelines you can pretty much use it wherever you want to. So that's a good pro and con thingy. Yeah. So yeah, I mean, if you're a fan of kind of low code CI/CD, I would choose GitHub Actions. But if you want to just build your own CI/CD pipeline,
yeah,
Tecton is the way.
yeah. The learning curve of Tecton is a bit higher. Let's say it
Bit
like that.
higher, correct?
Yeah, yeah,
Yes.
yeah, yeah. Okay. We don't have any other question. Yeah, Satamis, I'm seeing blurred letters on the codes. Maybe. Okay. Maybe your resolution was too low of the video. Maybe you can watch the replay and enhance the video quality. That will maybe help. And I think you will also share the maybe a GitHub repo with the
Yes,
the
we'll share the repository as well, so you guys can take it out. Check it out, the .github/workflow directory for all the YAML files.
Okay. Hey, we need to wrap up. That was the last event of DevNation of 2021. It's
Wow.
time for some holidays now for some of us, and but we will be back next year with great content, tech talks, the show, deep dives. So maybe other DevNation days for sure. I'm almost sure. And yeah, thank you so much, Karan. And
Right, Sabi, thank you so much. Thank you, audience, for watching the live stream.
yeah,
And yeah,
have
have
a
a good
good evening, everyone.
you
Stay
too.
safe and
See
see you
you.
next year. Bye
Cheers.
bye.
Bye.